Hello everybody, yes, my name's Paul Abel. I am a theoretical physicist at Leicester University, but today I'm here in my capacity as director of the Mercury Venus Section. We have a very nice elongation of Venus coming up. So what I want to do in this talk is really just talk about some of the things you can observe. That will be basic visual observation, or the kind of stuff that I do, that David just mentioned, but also the more advanced stuff, because we have some very interesting things happening on Venus, which some of us, most of us, are reasonably convinced is volcanic in origin. So, planet Venus, you may have noticed, first of all, it's a very, very brilliant object. It's very, very bright. You can notice it straight away as soon as it gets fairly dark. And one of the things you'll notice if you follow it over the course of an elongation is it behaves quite differently from the outer planets, from Mars, Jupiter, and Saturn. For one thing, Mercury and Venus can never be seen at midnight. So they're either morning objects or evening objects. And the reason for this is entirely due to the orbit. So I've got a little orbital schematic here. You've got to pretend the Earth is somewhere along here, and we're looking back in towards the inner solar system. So we have the Sun at the center, and Venus is moving around like this. And if we start off here at position number 1, this is superior conjunction. That means the Sun is between us and Venus. Venus then moves into the evening sky, and as you can see, it's coming closer towards us, and the phase is decreasing. So we get to half moon phase dichotomy, and it becomes a crescent. Then Venus passes between the Earth and the Sun. That's a point called inferior conjunction, and the planet then moves into the morning sky, and the whole situation goes on again in reverse. So we then have the crescent, the half moon back, and then all the way back to superior conjunction. So that's how Venus orbits in the sky. When it's on this side of the picture, we say it's in an eastern elongation. It's in the evening sky and on the eastern side of the Sun. When it's in the morning sky, we call that a western elongation, because it's on the western side of the Sun. Now, we were at position 5, inferior conjunction. That happened last on the 9th of January, and the planet has then continued to move into the morning sky. We're now somewhere between position 8 and 1, with superior conjunction occurring on the 22nd of October next month. And then after that, Venus will appear in the evening skies, and things will be quite good for the UK, because the planet will be in the winter sky. It will be quite high up, and so very easy to observe. It takes Venus about 225 days to go through this cycle, and we have these 8-year periods where Venus comes back to exactly the same point in the sky every 8 years. So the first observations of Venus didn't tell us a great deal in terms of planetary science, but it did an awful lot for celestial mechanics. In particular, these are Galileo's drawings, and you can see he doesn't show a great deal on the disk, but what he does show here is the phase. So we have the half here and the crescent, and it getting larger as it comes closer. And this was really the first hint that the Earth is not at the center of the solar system, and that we live in a solar system where the Sun is at the center and the planets orbit around. And the reason being is because you can't have these kinds of phases if you don't have the Sun at the center of the solar system. So it was very important from that point of view. But subsequent observations of Venus didn't reveal an awful lot. A couple of transits that were very useful. The first one being in 1639, Jeremiah Horrocks observed the transit of Venus. But I think perhaps the most influential one was one of 1761, where Mikhail Lomonosov observed a thick luminous ring around Venus, and he correctly attributed this to a very thick atmosphere. Something that was kind of suspected by then, but this was the first direct evidence. There were further observations after that in 1790 by SCHROTER. He observed the crescent extending beyond the poles, but really that was all people could do. When you look at Venus through telescopes, particularly those early telescopes, there wasn't a lot on the disk. And we had to wait until the space age to tell us what Venus was really like. And the first spacecraft to get there was Mariner 2. It got there in 1962, and it got to within something like 35,000 kilometers of the cloud tops. And there were two competing theories at the time. Some people thought that Venus might be kind of like a lush paradise, a little bit warmer than Earth, with vast tropical vegetation. Other people thought it might be a very featureless, windswept desert. And in fact, a lot of our early thinking about Venus was really quite wrong. It revealed, the spacecraft in particular, revealed that the surface temperature was about 500 degrees Celsius with incredible 75 to 100 atmospheres of pressure. So it really is more like hell than a tropical paradise of the earlier thoughts. In February 74, we start to get some nice images with UV filters taken on, and you start to see this wonderful cloud structure that you see, which you can see with a UV filter from Earth. You get these very striking cloud patterns that just aren't visible in the usual visible wavelengths. I think this is one of the nicest pictures of Venus. It's the picture of the surface. And it was only the Russians that have managed to get down to the surface of Venus. Venera 1, 2, and 3 all malfunctions, possibly due to decimal points being placed in the wrong place. Venera 4, 5, and 6 were completely destroyed by the atmosphere of Venus. They did manage to confirm an atmosphere, 95% carbon dioxide, but they were completely obliterated before they got down. So Venera 7 was made of sterner stuff and managed to get down there onto the surface. It lasted for 23 minutes, and during that time, it found some interesting things in the clouds. But we've got this lovely picture here. You can see it's a very, very volcanic surface, this kind of rocky picture here, and this angry, glowing yellow sky. The atmosphere on Venus is incredibly thick, and if we were to be standing on the surface in a pressure suit, then it would be about as bright as this moon, about bright as this room. Even though it's a lot closer to the sun, the thick atmosphere makes it quite dim. Then the next most remarkable picture, I think, is this. This was taken from Magellan. If you want to map the surface of Venus, you have to find a way of peering through all the clouds, and the real way to do that is with radar. So we have this surface map which bounces the radar waves off the surface. The higher regions are the brighter ones, and then lower down are the darker regions. And one of the most remarkable things we see, and this still really hasn't been answered in any meaningful way, is that the surface of Venus is all about the same age. Now that sounds like a trivial observation until you start to think about the rest of the solar system, in particular our own moon and Mars and Mercury. If we look at those kinds of worlds, we see very heavily cratered terrain and very smooth plains. So if you look up at the moon, you see the Sea of Tranquility and all the darker regions, as well as terrain that's been heavily cratered. And that's because the older terrain, which has been heavily cratered, is there because of the time of early bombardment, when the solar system was quite a dramatic place. And you see this mixed match of surfaces on a lot of the satellites and planets in the solar system that have solid surfaces. With Venus, you don't see that at all. All of the surface appears to be exactly the same age. It is almost as if some sort of massive upheaval went on Venus millions of years ago, and the surface was completely restructured. And I've still never had any convincing explanation as to why that should be the case. It could perhaps be the interior of Venus being quite different to the Earth, and maybe the heat has to escape out in one large explosion, but it's still really not quite clear. One of the things you do get, if you zoom into this image, is these interesting pancake-shaped objects. And this is really evidence of volcanoes on Venus. A lot of professional planetary scientists think that the volcanoes of Venus are actually fairly active. We've just never caught them in the act yet, but we might be able to do that, and I'll come on to that later. But there's other evidence as well for ongoing volcanic activity, mainly changes to the level of sulfur dioxide in the upper atmosphere, and infrared flashes that were recorded by the European Space Agency. We don't think those could be hot lava, but something erupting. So although we don't have any direct evidence of active volcanism on Venus, we do have all these little telltale signs which would point to active volcanism going on the planet. Okay, so when is the best time to observe Venus? Personally, I do it during the daytime, usually when I'm not teaching. I have to come home and do it. Weekends are a better way of doing it, and I find observing in the daytime is very good, because if you're a visual observer, you find that the glare of Venus is really, really reduced. When it's late in the evening and quite dark, although Venus looks very, very prominent in the sky, it's very, very difficult to observe. So the way to do it is in the daytime. This method works, but please don't try it unless you're very, very experienced. What you have to do is essentially get the right ascension of declination of the sun, and then you project the sun through your finder scope, and then set the dials, and then rotate the telescope to the right ascension and declination of Venus. But if you're in any way inexperienced with this, don't do this particular method, because if you catch a look at the sun, instant blindness will result. So a lot of people wait until it's just about dark, and Venus can be seen as a faint point of light in the evening or morning sky. So that's a good time to look. Often the scene is quite stable then, so it's not being distorted by the tumultuation of the ripples in the atmosphere. So that's the best time to observe, and at the moment Venus is quite close to the Sun, so we have to wait a bit, but after October into November, December, it will be quite a distance away, enough to make a start on observing it in the evening sky. So what about observing Venus with a telescope? Well, if you use a telescope, you can see a number of things. Most people think Venus visually is quite bland. It's not. There's all sorts of subtle features there. You just have to know how to look at it. I use my 8-inch Newtonian reflector to observe it. You can use any telescope you like. A 3-inch telescope is probably the minimum requirement, but it doesn't have to be a Newtonian. It could be an SCT. If you're going to try imaging, which I'll talk about in a minute, remember that some of these telescopes have corrector plates that might interfere with that. Also, a sidereal drive is incredibly useful. You don't have to have a go-to, but some mechanism of keeping sidereal time so that your telescope tracks is a very, very useful thing, because even at a medium magnification, it's remarkable how quickly planets move through the telescopic field of view. So we've had earlier Sandra mentioning how important it is to keep a record of where your observations were, date and time, and so on. I cannot stress how important it is to try and keep some sort of logbook record. You may think, oh, I'll remember what I saw a few days ago, but 3 weeks later, especially over Christmas with a few drinks, you won't remember a single thing, and it will all be lost in the midst of time. So the way to do it is to write it down. And I keep a logbook for all the different planets I observe. I keep a logbook. In fact, this is my only real connection with observational science, so I like to make sure I keep an up-to-date logbook. We've called essential things. I've got at the top, I have date, time in UT, the telescope used, where I made the observations, and some drawings that I stick on there. So these are the sort of things you should record, even if you don't see anything, even if you observe Venus and all you saw was the phase, that's still worth putting down. And then over a course of an elongation, you'll be able to track all of your observations that you've made. And if ever you want to follow up on a particular observation, there it all is in a logbook. I do recommend logbooks. Initially, when I started, I had a ring binder folder, but one day it opened and all of the observations, I thought, I am never going to go through this again, sorting them out, putting them all back into chronological order. So that won't happen if you use a notebook that's bound properly. So I would recommend doing that. It just makes life a lot easier. So apart from a telescope, what else do you need to observe Venus? Well, most telescopes come with these. Okay, this is an optical filter. So it allows some light of the visible spectrum to pass through, but not others. And each of them are identified. You may not have noticed this, but there's a little tiny number on the side of your filter. This screws into the barrel of the eyepiece. You can see this is number 15 and it's yellow. These are the Ratten numbers. They were invented by Kodak way back in the 1920s for color photography, and they still retain these numbers. So Ratten 15 is yellow, Ratten 21 is orange, 47 is violet, and they're really incredibly useful for visual work because they allow you to look into different depths of the atmosphere. Okay, so if you put a yellow filter on, you'll see the cloud markings on Venus, if you can see them, look quite a bit different in yellow as they would in orange or in blue. Some other things I could recommend: Venus blanks, so you can make your drawing quite quickly, and WinDupos, this free software, is incredibly useful. It will tell you all the technical detail about how large, how diameter of Venus and what its phase is. So some very useful things there. And when you look at Venus through a telescope, don't be surprised if initially you don't see an awful lot, that you just see a little disk. It takes a little time to build up what you can see, but there are some standard features that are always usually present. We have these bright cusp caps here. I don't know how well you can see at the back, but these regions covering the poles, these are quite bright. They're not static. In fact, these are very dynamic places on Venus because we have these vortices and winds going on up here. So sometimes the North Polar cap, the North cusp cap might be large. Other times the Southern cusp cap might be large. Sometimes they vary in brightness. But they're usually always this little dark color either side of them as well. And then you get these sort of vague streaks. And there's this bright region on the end here, which is called the bright limb band. And the markings really dependent on what kind of eyesight you have. If you're more sensitive to the shorter wavelengths, the bluer end of the spectrum, you'll find it much easier to see the markings, because Venus's markings in the upper atmosphere, at least, they are most dominant in UV wavelengths. So I'm not going to go too much about this, but if you want to make a drawing, you can go to the BAA Mercury and Venus Section website, and you can download one of these forms and print it out, and you can see all the little prompts here to remind you to put the date, time, and telescope details in. And if you, some people send these in by post, most people now scan them and then email them in, but it is a very, very good way of keeping track of your observations. So I would recommend doing that. If you haven't got access to a blank, then you can just download this form. A couple of other things to watch out for. The first one is called the SCHROTER effect. This is a phenomenon almost entirely unique to Venus. If you look at Venus on any given evening, you'll find that the phase you observe in the telescope is actually a little bit less than the theoretical phase, and that's called the SCHROTER effect. And the reason we think is because Venus's atmosphere scatters blue light more than the rest. And if you look at these drawings here, this is a drawing I made way back in January 2017. So it's predicted, Venus is predicted to be at about 56%, but you can see visually it's practically 50% illuminated, and that's the SCHROTER effect. So the theoretical phase is always a bit larger, and this varies. The SCHROTER effect isn't constant. In some elongations we find quite a large SCHROTER effect, in others we don't. So again, that might point to ongoing activity on the surface, and it's something you can do very easily. All you have to do is draw in the terminator on your blank as quickly, as easily as you can. So just put it in as accurately as possible, and then measure this distance. So in this particular picture I have here, this distance on paper, not on the screen, is 32 millimeters. The blank is 50 millimeters in total. So all I do is 32 divided by 50, and that gives me the measurable phase of 64%. And if you do that over a course of time, you'll see that your observed phase is always much less than the theoretical one. Believe it or not, this is something best done for visual observation. As you'll see when I bring up some images in a minute, the terminator of Venus in images is actually quite diffuse and quite hard to define. So the terminator is much sharper visually. So this work tends to be done by visual observers rather than just from images. Now, there is a curious phenomena from the annals of observation of Venus, and that is something called the ASHEN light. How many people here have heard of the ASHEN light? How many? Keep your hands up if you believe it to be a real phenomena. Nick doesn't count. Yes, it's an interesting one. I remember I used to chat to Patrick about this quite a bit. He was insistent that he'd seen it. I was equally insistent that he hadn't. But it's an interesting phenomenon whereby the night side of Venus appears to glow. In fact, this is one of Patrick's drawings. You can see here we've got the bright crescent that's really bright, but we've got the night side apparently illuminated against the dark sky. And some observers, a lot of observers these days, tend to think that the effect is entirely illusional. I was of that opinion until a little while ago. And then this result came along. This is the Parker Space Probe. Lynn told us about this earlier. This is the craft that takes lots of useful data of the sun. Lynn thinks it's useful because it provides nice pictures of the sun. I think it's useful because of this result it's done with Venus. So in February 2022, the spacecraft passed by Venus and imaged it in the near infrared. Now, what's interesting about it, can you see these darker patches here? This is the night side, and this is structure from the surface coming through the night side. And the astronomers that were examining this were really quite surprised, because some of the wavelengths that we're looking in here are in the visual. The human eye would be able to detect them. So a series of questions, there was a series of papers about this, and in one of the papers, people wondered if perhaps the thinning of the atmosphere might allow the glowing hot surface to be seen, and that might be the cause of the ASHEN light. I don't think this in any way proves that, just to be quite clear, this is not a definitive result, but if there is ongoing active volcanism on the planet, I don't think it requires a great leap of faith to think that maybe, say, at times the surface is much hotter than usual and that affects the atmosphere, and that may allow us to look through, and certain observers may have seen the ASHEN light. What's interesting about the ASHEN light is it's not constant. It's often we'll see in the evenings, in the mornings, and there have been whole periods and decades where the ASHEN light has been very, very faint and not really been seen at all. So it's just an interesting thing to follow up, that this might be an explanation for it. Then again, it might have no connection with it at all. But I don't think it means that, I think this means really that the ASHEN light mystery still hasn't been solved, and there might be something more to it. Okay, so that's visual observations of Venus. We can move on now to imaging. Most people have images, a good image setup, and they like to take pictures of the sky. Most digital observers in the Mercury and Venus section seem to use SCTs. C11s, C14s are by far the most popular, presumably because they are very easy to maneuver about and give very good results. So observations that you can make with this kind of kit are observations in the infrared, near infrared, and UV. Those are things that we simply can't see visually. So this adds all sorts of extra stuff that we can look at. And in particular, there is some interesting phenomena that's still going on that can be recorded in infrared. So this is a typical sort of infrared image of Venus. You can see, this is by Anthony Wesley. You can see the terminator here, as I mentioned earlier, is really quite diffuse, so it's quite difficult to tell when the hard boundary is. But you can see some vague markings on the disk, but usually that's about all. UV filters reveal the most structure, but the thing of interest is this thing here. Can you see the line moving? Yeah? Let's just about see that. There's this unusual linear feature in the atmosphere of Venus moving backwards and forwards. This was a sequence of images taken by Antonio Cededo. What is that? It appears to be an enormous standing wave in the atmosphere of Venus. Heaven knows what causes it. It was actually first imaged by the Akatsuki spacecraft from December 2015. So it was first sighted by a spacecraft, not by amateur astronomers. It appears to be about 10 kilometers going north to south and covers about 95 degrees in latitude. But then these observations were made by amateur astronomers in October and December of 2016. And again, between 2019 and April 2020, the phenomena came back, and lots of independent amateur astronomers, very good ones, sent in their images. And from that, Richard McKim and myself were able to establish that it had about a 4 to 5 day rotation, so in keeping with the upper atmosphere of Venus. And the phenomena is still there. It came back again this year. Here's some images of it. It's perhaps more easy to see. Now you see we've got this dark line here that we thought was a shadow. The jury's still out of what it might actually be. But this big welling up of clouds either side. And this has persisted now. I have an image from last week from somebody, an observer in Spain, who managed to image it and show it on the edge of the disk here. And you can see it only appears in infrared. These are the same observer who's used UV as well. You can see this feature is only appearing in infrared. How on earth it could stay there, as well as keep its shape in the atmosphere of Venus, is a complete mystery. But it's still ongoing. This is the recent image I have of it. This was the 2nd of September. You can see it's still there. And there really isn't much of an explanation as to what could be doing it, much less what could be powering it. You've got two problems. What could produce the amount of energy to create this phenomenon in the atmosphere, and what sustains it? Because it's very strange that it should keep this very definite linear shape that it has. Okay, UV images, you get the lovely structure of clouds here, and they can be quite complex. So if you put a UV filter on, you'll see there is quite a bit of structure in the clouds, and it's always been nice to track that, because from that we can then measure the atmospheric rotation of Venus to see if it's changing. And in particular, Chris Doll, this isn't one of his best images actually, but he does send in some very nice images capturing the cloud bands. This one is by Phil Miles in Australia, and we can see we get very, very complicated cloud patterns that we don't see with the naked eye. So UV is very, very useful. And then the final point I'd really like to bring home is it's maybe possible now for amateur astronomers, and this is really remarkable, it just shows how much amateur astronomy has advanced in the last 10, 15 years, might now be able to capture volcanoes on the surface of Venus that are active if they're going on. And we have here some tantalizing piece of evidence. This isn't definite evidence of volcanoes on Venus, but it's the sort of way you would go if you wanted to try and prove it. These are a series of images produced by Anthony Wesley with Phil Miles, and what I'd like to draw your attention to are these bright hotspots on the surface. So this is the night side of Venus. You can see we've got the overexposed crescent here, and you can see we've got this hot spot that maintains the same place that isn't on. It also keeps with the planet's rotation. So we know it's not an artifact because it's rotating at the same rate as the surface, it's rotating in the same direction as the surface, and furthermore, it's not always there. But what we need is follow-up observations. An N of 1 is an N of none. So we need more data points and more observations. And it just so happens that Venus is going to oblige us with that by being in a nice position next year. So dichotomy occurs at position 3 here on the 4th of March 2023, and from then on Venus will be becoming a crescent. The best time to try and image the night side of Venus is when the crescent is quite small and Venus is a lot closer to us. You will need to do this in infrared. It is not a trivial operation to do. It does require some skill, but the section newsletter messenger, which is available online, has details about how to do this, because a number of amateur astronomers in our Mercury and Venus section have got some very, very good images. Anthony Wesley wrote a piece about it, and Peter Tickner as well, on how to go about doing this. In fact, some people are now using their own homemade infrared filters to try and record this. So I would urge you all, those of you who have imaging setups, to start imaging Venus in earnest when it's in this phase, really then from March to August, to see if we can find any hot spots on the surface of Venus. You should try and take a couple of images so you get the planet's rotation so that we know they're not artifacts. And if you do find any hot spots, please let me know. Please send them in to me by email. Make sure you've got date and time on there, your telescope details, and we can use those to correlate to see if other observers have them as well. If you want advice on imaging Venus, I'm actually not the person to ask because I don't do a lot of imaging, but we have plenty of expertise in the section. So Chris Hooker, our Mercury director, Mercury coordinator is very good, Chris Doll, and Mr. President, David Arditi, is Director of Instrumentation and Techniques in the BAA. He'll be able to help you an awful lot. One more thing, as we've all come north to you today, perhaps you might consider coming south to Winchester. We're having a section meeting in Winchester in 2023. Anne Davis told me that we were having a Mercury and Venus section meeting there. So it would be good if as many as you come down. A lot of people in the, I try to make section meetings as observationally based as possible. So we'll have a lot of people from the section talking about their imaging setups, the things they've been trying, talking to us, and it will be a very, very good place for you to get any hands-on help and advice if you want it. Okay, I'm just 2 minutes over. I can see Nick twitching, waiting to get off. So, thanks very much for your attention, and if you have any questions, let me know.
Any quick question for Paul?
Yes.
One in the back here.
Do you mean the scientific one or mine? Well, I think it's more data points. I think we need more evidence that it's there. And I think there's talk of sending a spacecraft to Venus to deliberately look for it. If it is there, we have to explain why it's there. I'm not at this moment in time convinced it is a byproduct of life. We have to be quite careful with looking at the other planets. Venus is not the Earth. Phosphine might be a biosignature here. That doesn't mean it's so on Venus. So I'm going to give you the typical theorist's answer. I don't know, and I'm not sure when I will know, but one day we will know.
Yes.
Yes, that's a good point. I should have put that in here. Yes, absolutely.
Okay, and Dennis.
Over the centuries really of observations of Venus, there's been various projections from the limb,
Yes.
bright spots appearing outside, you know. Are these all illusions?
Well, I don't want to say yes, but let's just say the quality of optics in the 17th century, perhaps not quite as good, it's worse than it is today. It is a fact, though, that those kinds of unusual observations have been seen. So there's something called the cusp anomaly, whereby you're supposed to get a nice smooth terminator, but sometimes it's much flatter at one of the poles. And a couple of years ago, I drew that, and Bill Leatherbarrow in Sheffield imaged it at the same time. And sometimes you do seem to get extensions, in particular when Venus is close to inferior conjunction, you do get these extensions. It's a very thick dynamic atmosphere, and strange thing happens when you've got sunlight passing through thick atmospheres. So I wouldn't rule it out, but they're probably quite rare. What's really sad, unfortunate, is we don't have any images of that. And it's because it seems to happen when the phase is quite low, and a lot of images have stopped by then because Venus is very low down and difficult to image. So those of you who image, put some effort in. Follow Venus to inferior conjunction.
Right, we have with that ringing call. We'll halt to that and say thank you.
Thank you.